Ever wondered how crucial IP addresses are to the world of networking? Let's dive in. You see, IP addresses are like the street addresses of the digital world. Each device connected to a network has a unique IP address, just like how each house on a street has a unique address. This unique identification allows devices to send and receive information to and from specific places within the network. Imagine trying to send a letter without an address. It would be lost, right? The same concept applies to data packets on a network. Without an IP address, these packets wouldn't know where to go, leading to a breakdown in communication. So IP addresses are the unsung heroes, quietly ensuring that your favorite websites, your important emails, and your video calls reach their intended destinations. They are the essential threads in the vast web of internet communication. Without IP addresses, the internet as we know it would come to a standstill. But how do devices get these IP addresses? Enter the Dynamic Host Configuration Protocol, or DHCP. Now, let's delve into the world of DHCP. This is a network management protocol that does the heavy lifting of assigning IP addresses and other vital communication parameters to devices on a network. It's like the efficient manager we all wish we had. It takes care of the details so we don't have to. The DHCP server and client instances on each device work hand in hand, operating on a client-server model. The client requests parameters from the server, which then manages a pool of IP addresses and configuration information. The beauty of DHCP is that it can be used on networks of various sizes and supports both IPv4 and IPv6. But here's the real kicker. The DHCP operates in 4 phases: server discovery, IP lease offer, IP lease request, and IP lease acknowledgement. It's a streamlined process that keeps the network running like a well-oiled machine. So, DHCP keeps our networks running smoothly and efficiently. The first stage of the DHCP process is server discovery. Let's delve into this fascinating process. Picture a new device, let's say a laptop, joining a network. It needs an IP address to communicate on the network, right? But how does it get one? That's where DHCP steps in, and the first phase of this protocol is server discovery. The laptop, or any client device for that matter, broadcasts a message known as DHCP Discover. This message is like a flare shot in the dark, a beacon calling out to any DHCP server within the network. It's essentially the client saying, "Hey, I'm new here. Could use an IP address to get started." Now, this message isn't just sent out willy-nilly. It's sent using a protocol known as UDP, or User Datagram Protocol. UDP is like the courier service of the internet. It delivers these messages without requiring a direct connection between the client and server, making it a connectionless protocol. And just like how courier services need addresses to deliver packages, UDP uses specific port numbers to ensure these DHCP Discover messages reach their destination. The client sends this broadcast message to a reserved port, port number 67, which is set aside just for DHCP servers. But wait, how does the server know where to send the response if the client doesn't have an IP address yet? Well, that's the brilliance of DHCP. The server sends its response, a message known as DHCP, to a special IP address called the broadcast address. This address ensures that all devices on the network receive the message. The client then listens for these DHCP messages and picks one to accept. Once a client has located a DHCP server, it's ready to move on to the next stage. But that's a tale for another scene. For now, just remember that the server discovery stage is all about the client broadcasting its need for an IP and the servers responding with their offers. It's a little like an auction, but for IP addresses. After server discovery comes the IP lease offer. This is the second phase in the Dynamic Host Configuration Protocol, or DHCP, process. So, what exactly happens in this phase? Well, it's all about the DHCP server responding to the client's broadcast. You see, when a device first connects to a network, it's like a stranger in a new town. It doesn't know its way around, and it needs an address to establish its identity on the network. This is where the DHCP server steps in. Think of the DHCP server as a kind of town hall for the network. It has a pool of IP addresses ready to be assigned to new devices. When it receives a broadcast message from a client, the DHCP Discover message we talked about in the server discovery phase, it picks an IP address from its pool and prepares to make an offer. The DHCP server then responds to the client's broadcast with a DHCP message. This message carries the offered IP address. It's like the town hall saying to the newcomer, "Hey, here's a vacant lot you can build your house on." But the DHCP offer message contains more than just the IP address. It also includes other important communication parameters that the client needs to operate on the network. These might include details like the default gateway, the subnet mask, and the DNS server address. All these details are neatly packaged into the DHCP offer message and sent back to the client. This process is done automatically and swiftly, ensuring the client doesn't have to wait around too long before it can start communicating on the network. Now the client has an IP address offer in hand. It's one step closer to becoming a fully fledged member of the network community. But before that can happen, there's another important step to take: the IP lease request, but we'll delve into that in the next scene. Stay tuned. The third stage of the DHCP process is the IP lease request. Now this stage is where the action truly begins. It's like the heart of a conversation, where the client finally responds to the server's generous IP lease offer. The client, upon receiving the DHCP offer, doesn't just sit idle. It takes the initiative to confirm its acceptance of the offered IP address. This is done by sending a DHCP request message back to the server. It's like saying, "Yes, I'll gladly take that IP address you've offered. I accept your terms." Now, this might seem like a simple interaction, but it's a crucial part of the process. It's the client's way of saying, "I'm here, I'm ready, and I'm accepting the IP address you've assigned." It's the equivalent of shaking hands on a deal or signing a contract. It's formal, it's official, and it's absolutely necessary. The DHCP request message isn't just a nod of approval, it's a beacon of intent. It's the client's way of signaling to the server that it's ready to take up its place in the network, to start communicating with other devices, and to become a part of the larger digital conversation that's constantly taking place across networks worldwide. But remember, this isn't just about the client. The server is also a key player in this interaction. It's the server that patiently waits for this request, ready to move on to the next stage of the process once it receives this confirmation. So, the IP lease request isn't just a step in the process, it's a vital link in the chain of communication between the client and the server. It's a testament to the brilliance of the DHCP protocol, ensuring smooth, automatic, and efficient network operations. With the IP lease request sent, the client is almost ready to start communicating. Finally, we reach the IP lease acknowledgement stage. In this phase, the DHCP server sends a DHCP message back to the client. This message is the server's way of confirming the lease of the IP address to the client. It's like the server saying, "Yes, you can have this IP address. It's yours now." This DHCP message is a crucial part of the process, as it ties everything together. It's the final handshake that concludes the DHCP process. It's the server's green light that sets the client ready for action. With this acknowledgement in place, the client now has the IP address it needs to start communicating on the network. It's like a new kid on the block who just got introduced to everyone and is now ready to play. And there you have it. The client now has an IP address and can start communicating on the network. And let's recap what we've learned about DHCP. This nifty protocol, Dynamic Host Configuration Protocol to be precise, is the unsung hero of our networks. It works tirelessly to automate the assignment of IP addresses and other communication parameters to devices. No need for manual configuration here, folks. Now, remember the 4 stages of the DHCP process? First, the client device kicks off the process with server discovery, broadcasting a request for an IP address. The DHCP server steps into the spotlight during the IP lease offer stage, where it offers an IP address from its pool. Next up is the IP lease request. Here, the client accepts the server's gracious offer by sending a DHCP request message. Finally, in the IP lease acknowledgement stage, the server confirms the lease of the IP address to the client. So you see, DHCP is not just a protocol, it's a dynamic conversation between devices, ensuring smooth network communications. Understanding DHCP is key to understanding how our networks keep us connected each and every day.